Lauren, can you hit that light switch back there, please? We're going to start with section 7.4. There's just a couple things from 7.4, and then 7.5 has a little bit more to it. And it probably will take a little while to get through this. It's not real difficult stuff, but there is quite a bit of it. And you're going to find as we do this, you're going to see a lot of proportions, just like you have all the way through this chapter. Same thing will continue here with sections 4 and 5. All right, let's see. Today is Tuesday, March 2nd. And as you're getting that written down, just keep in mind when we start chapter 8, we're going to want scientific calculators. If you have one already, that's great. If you don't have one, you can either go out and get one, or if you want, you can check one out from me. You just have to remember to bring an ID with you to check it out from me each day. But remember that on tests and quizzes, you will not be allowed to use your cell phone as your calculator. So try not to get yourself in the habit of using your cell phone. Calculator. All right, section 4. We're going to start off with something new, and then we'll go back to what you did on that GeoGebra yesterday. So the first, I think we have 2 theorems here in section 4. Yes, just 2. The first one is called the triangle proportionality theorem. And of the 2 theorems you get in section 4, this is the one we don't use as much as the other. The theorem you did on GeoGebra is the one we'll use the most. And we're going to do this theorem with just a picture. It's called the triangle proportionality theorem. So obviously we need a triangle. I'm going to draw the triangle like this. And in the triangle, parallel to one of the sides, it doesn't matter which side, I'm going to go with this side over here on the right. We're going to have a side coming through the triangle that's parallel to this right-hand side of the triangle. And what that's going to do is split your triangle up into 4 parts. And just for simplicity's sake, I'm going to call these A, B, C, and D. And what the triangle proportionality theorem says is if you've got one side parallel, or you got a line going through your triangle that's parallel to one side, it splits the triangle up into those 4 parts. Those 4 parts will be proportional. And when you go to set up your proportion, again, you can set up the proportion a lot of different ways. I'm just going to set it up the way it is over here. We've got A and C on the left. I'm going to put them on the left. You've got B and D on the right. I'm going to keep them on the right. And that's really all there is to it. So when you got that line parallel to a side of the triangle, splits it into 4 parts, those 4 parts are proportional. Now let's show you an example of how this looks. Usually they're going to tell you to find X. And my guess is if you have this on a test or quiz, you're probably just going to see one of them. It would be unlikely that you have more than that. So if this was a test or quiz, you might expect to see one of these on the test or the quiz. All right, here's how we're starting our picture. We've got the triangle. We're drawing a segment through the triangle that is parallel to one of the sides of the triangle. and they're going to tell us the following. We've got a 7.5 over here. This part is 3. We have a 2.5 down here. And the x they want us to find is this part. And just like all chapter long here, when you're doing these proportions, don't be surprised if you get decimals for answers. That does happen quite a bit. On this one, I think we end up with a whole number, but a lot of times you will get decimals. So if you look at it, you've got your side that's parallel to a third side of the triangle, splits the triangle into 4 parts. Triangle proportionality theorem says those 4 parts will be proportional. On the right here, I'm going to put together a proportion. Once again, you can set up the proportion a lot of different ways. I'm going to keep it real simple. Since x and 2.5 are on the left, I'm going to keep them on the left. 7.5 and 3, they're on the right. I'm going to keep them on the right. Those 4 parts are proportional. And then just like we've done all chapter long, cross multiply to solve. 3 times x is 3x. 2.5 times 7.5. What is it?
18.75.
18.75. And if we divide that by 3, we are going to get 6.25. I was thinking we'd get a whole number here. We did not. We got a decimal. So once again, don't be surprised if you get decimals. That does happen quite a bit when we're doing these. All right, there's the first one. Anybody need to see another one of those? Okay. The second theorem you got was called the triangle mid-segment theorem. I think I'll start a new paper for this. This is the one you did yesterday on GeoGebra. It's going to be very, very similar to what we just did. And again, I'm going to draw this with a picture. All right, for our picture, we're going to start with the triangle. And then the mid-segment part, we're going to go back to yesterday. We defined yesterday on that GeoGebra, we defined a mid-segment as going to be, it's a segment that connects the midpoint of 2 sides of a triangle. So I'm going to draw it coming through here. Basically, we'll do this. If I split this side into 2 congruent parts, and I split this side into 2 congruent parts. The segment that connects those midpoints is called the mid-segment. And just to help us out here in a little bit, let's go ahead and label these parts A, B, C, D, and E. And the triangle mid-segment theorem is going to tell us 2 things. It's going to tell us that, I'm going to go ahead and write this part here. Mid-segment of a triangle is going to do 2 things. First one, if you go back to the GeoGebra yesterday, this segment BE is going to be parallel to the third side of our triangle, CD. So BE connects 2 sides of the triangle. It's going to be parallel to the other side. So here's the first thing here. We're going to get BE is parallel to CD. Anytime you have a mid-segment on a triangle, it's going to be parallel to the third side of the triangle. And then the second thing is the length of it. The length of your mid-segment, BE is our mid-segment here, its length is going to be half the length of that third side, which is CD. And I think above mid-segment here, I'm going to put in parentheses BE. E is our mid-segment on the picture. That mid-segment will do two things. It's going to be parallel to the third side. It's going to be half the length of the third side. And that's what we learned yesterday in GeoGebra. All right, once again, I'll give you an example of what this will look like. Typically, we're going to use this second part when we do the problems on our homework and our tests and our quizzes. So let's see here. Let's come up with a problem. On this one, I'm going to draw in all three of the mid-segments on the triangle. So here's our first mid-segment. It's going through the middle of those two sides. It's going to make those 2 points midpoints. And if I come down here and split this side in half, if I connect here, I've got another mid-segment. And if I connect here, we have another mid-segment. And this time they're going to make us find two things, X and Y. All right, let's start with this part here being X. This entire side here is going to be Y. And this mid-segment is 8. And on this bottom side, this half is going to be 10. And as soon as I know that half is 10, that makes this half 10 also. And from that mess right there, we're going to be able to find X and Y. To do this, we're just going to use our triangle mid-segment theorem. So once again, remember, if you have a mid-segment on a triangle, two things are going to happen. It's going to be parallel to the third side of the triangle. It's also going to be half the length of the third side of the triangle, which is what we're going to use on this problem here. So let's start with X. X is the mid-segment. The side it would be parallel to would be the bottom. So this would be the third side of the triangle. The bottom side here, if you put those two together, 10 plus 10 is 20. If this entire length is 20, the mid-segment is going to be half the length of this side. That whole length is 20. Half of 20 is 10. So X is going to be 10. And then to get Y, we have to go the opposite direction. Y is the entire third side. They tell us the mid-segment is 8. Now, if you remember, your mid-segment is half the length of the third side. So if this mid-segment here of 8 is half the length of the third side, what would this entire side have to be? 16. Okay. Finding these is just going to be a matter of multiplying or dividing by 2. If they give you the mid-segment, multiply it by 2 to get the length of the side. If they give you the length of the side, split it in half to get the length of the mid-segment. This is what you did yesterday on GeoGebra, this part right here. You may need to see another one like this. Okay, that takes care of section 4. Now we're going to go to 7.5. And again, we got some theorems. They're not terribly difficult. There are several of them. I think we got 4 or 5 of them this time around. All right, these don't have names to them, so we just have theorem numbers. We're going to start with theorem 7.8. what? I think I'm going to do this differently. Scratch that off. These first three theorems are all going to start the same way. So rather than writing them out 3 different times, we're going to do it this way. And then down here, I'm going to put theorem 7, 8. Start with theorem 7, 8. All right, if your two triangles are similar, first thing that's going to happen, we're going to start with altitudes. I spelled that wrong, altitudes. Your altitudes are going to be proportional to the corresponding sides. And here's what that means. Altitudes, if you remember back all the way, I think it was chapter 2, we talked about altitudes. Altitudes are kind of how tall a triangle is. It's going to go from the top of the triangle perpendicular to the opposite side. So here's what it'll look like. You're going to have two triangles that are similar to each other, which means one is bigger than the other. And then we're going to draw in the altitudes of those two. The altitude is going to come straight down and make a right angle with the bottom of the triangle. When you get those right angles there, you know you have an altitude. And I'm going to start to use some different letters here. Let's call the altitudes E and F. And our theorem says the altitudes are going to be proportional to a set of corresponding sides. So they'll give you a set of corresponding sides on the triangle. Sometimes they'll give you the bottom side, sometimes the left, sometimes the right. For this one, let's go with the left sides. G and H are going to be the two corresponding sides of the triangle. And then just like we've been doing all chapter, they're giving you 4 parts here. The theorem says those 4 parts are going to be proportional, so we'll set up a proportion. And just to kind of show you how I'm setting up the proportion, because there's a lot of different ways you could set up the proportion. What I'm going to do is I'm going to put the altitudes on the left, and I'm going to put the corresponding sides on the right. So if I take a look at my left-hand triangle here, that altitude is E. I think I want to change the way I do this. Since I have a left-hand triangle, I'm going to keep those on the left. I have a right-hand triangle, I'm going to keep those on the left. I'm going to put the altitudes on top. I'm going to put the sides on the bottom. I think it'll be easier for you to see how this is coming together if I do that. So the altitude of our left-hand triangle is E. I'm going to match that up with the altitude of the right-hand triangle, which is F. That gives us our altitudes on top. They'll be proportional to the corresponding sides. The corresponding sides are G and H. Since G is from the left, I'm going to keep it on the left. Since H is on the right, I'm going to keep it on the right. And then just like we've been doing, once you have your proportion set up, you'll cross multiply to solve for that. We'll get into the actual solving this here in a little bit. All right, there's our first theorem, 7, 8. Theorem 7.9 is going to start the exact same way. We're going to have two triangles that are similar to each other. Theorem 7.8 told us the altitudes would be proportional to a set of corresponding sides. In Theorem 7.9, our angle bisectors are going to be proportional to a set of corresponding sides. All right, picture for this one's going to look a lot like we just did. We're going to have two triangles. One's going to be bigger than the other. On the last one, we drew in the altitudes, which meant we had right angles when we drew them in. Now we're going to draw in angle bisectors. And we can bisect any of the angles. Usually you're going to see the top angle split in half. So I'm going to do that. This angle bisector right here is splitting that top angle in half. Put in an angle bisector over here. It's going to split the top angle in half. And then just like before, they're going to give you four parts. So the angle bisectors are going to be two of them. I'm going to call the angle bisectors M and N. They'll also give us a set of corresponding sides. I'm going to use the right-hand sides this time. We'll call them P and Q. And then just like before, those are going to be proportional. So we'll set up our proportion with four parts. And I think I'll do it like I did before. You can set up the proportions several different ways. I've got a triangle on the left, so I'm going to keep those numbers on the left. Triangle on the right, I'm going to keep them on the right. I'm going to put our angle bisectors on top. I'm going to put the corresponding sides on the bottom. Hopefully that will help you see where this stuff's coming from. Okay, it's just a matter of putting it together. Angle bisector on the left is M. That'll match up with the angle bisector on the right, which is N. Your corresponding sides are going to be P and Q. P is on the left-hand triangle, so I'm going to keep it on the left. Q is on the right-hand triangle, I'm going to keep it on the right. And then same exact thing. To solve that, you'll cross multiply and solve for x. We'll show you some examples of that here in a little bit. All right, last one, Theorem 7.10. It's the last theorem that starts this way. We actually have one other theorem after this. But this theorem is going to start the same way. You're going to have two similar triangles. And this time, our medians are going to be proportional to the corresponding sides. Let's get a picture of that. Again, we're going to have two triangles. One's going to be bigger than the other. Those two triangles are similar to each other. And on this theorem, we're going to draw in the medians. Medians are going to go from a vertex to the midpoint of the opposite side. So if I come out of this top angle, come down here and hit the midpoint of this side, that segment would be a median. I'm going to do the same thing over here. Segment coming out of the top vertex, it's going to hit the middle of the opposite side. I'm going to call those two medians V and W. And the medians are going to be proportional to a set of corresponding sides. This time I'm going to go with the bottom sides. This bottom side, we're going to call that Y. We're going to call this bottom side Z. And then same exact thing's going to happen. You've got 4 parts here. Those 4 parts are going to be proportional. I'm going to set it up the way I did before. I've got a left-hand triangle. I'm going to keep those numbers on the left. Right-hand triangle. I'm going to keep those numbers on the right. I'm going to put my medians on top. I'm going to put our corresponding sides on the bottom. When I do that, I've got V for my median on the left. It matches up with W, the median on the right. And then our corresponding sides, Y is on the left, Z is on the right. And that's all there is to it. All right, let's show you a couple of examples of this. I think you're going to find these pretty easy to do. Directions on this are going to tell us the triangles are similar. And then they're going to have us find X. We'll start with a couple of these and then we'll add on to it if we need to. All right, here's our triangles. Left-hand triangle, I've kind of got the bigger one there. Smaller one's going to be on the right. And with this one, we're going to do angle bisectors. And once they've got the picture set up, they're going to give you 4 parts. This angle bisector is going to be X. Right-hand side of the triangle is 15. This triangle over here, your angle bisector is 8. Right-hand side of the triangle is 12. What they want you to do here is set up the proportion to solve for X. You've got your 4 parts. Now you just got to set up the proportion. Now, like always, there's several different ways you can set up the proportion. What I'm going to do to keep it simple so you can see it, left-hand numbers, left-hand triangle, I'm going to keep those numbers on the left of my proportion. Right-hand triangle, I'm going to keep those numbers on the right of my proportion. And we've got angle bisectors here, so I'm going to put them on top. Corresponding sides, I'm going to put on the bottom. Here's how it goes. X is your angle bisector on the left-hand triangle. I'm going to put it on the top left. 8 is your angle bisector on the right-hand triangle, so I'm going to put it on the top right. Your corresponding sides are the 15 and the 12. 15 from the left-hand triangle, keep it on the left. 12 from the right-hand triangle, I'll keep it on the right. Now, before I go any further, are there any questions on where I'm getting this proportion, or did I confuse anybody on that? Okay, once you're there, you cross multiply. X times 12 is 12x. 8 times 15 is 120. Divide by 12 there, x is going to be 10. There's one with angle bisectors. Let's do one with altitudes. We'll start with our big triangle. Altitude, again, is going to have a right angle at the end of it. And we've got a 16 and a 20. Now, with this example here, they're going to add on a couple things. We're going to add in some angle marks so that we can line up our corresponding sides. Because on the right-hand triangle, they're going to flip it upside down. Let's see. Put in our angle marks here. Our altitude is going to be X. And they're going to give us both sides on this one. We've got 15 and a 9. So this one's going to be just a touch more work because they're giving us more than 4 parts. But we know our theorem says if you got similar triangles, then the altitudes are going to be proportional to a set of corresponding sides. So we're going to solve it with a proportion. And I'm going to do the same thing I've been doing all along here. Left-hand triangle numbers are going to go on the left. Right-hand triangle numbers are going to go on the right. Altitudes I'm going to put on top. Corresponding sides I'm going to put on the bottom. And now we just have to be careful to line up the corresponding parts correctly. So we'll start on the left. Left-hand triangle, your altitude is 16. That's going to be the top left. That's going to match up on the right with the altitude. The altitude on the right is X. And now the part we have to be careful. Our corresponding sides. The left-hand side, the only side they give us is the 20. And then to figure out which side that matches up with, if I look at the 20 is going from the angle marked with 1 to where the angle bisector begins, or where the altitude begins. So it's going from one angle mark to where the altitude begins. What would that match up with over here? 15. 15 goes from the angle marked with 1 to where the altitude begins. So we would use 15 for this one. And then again, once you're there, you just cross multiply. 16 times 15, 40. 20 times x is 20x. You divide by 20, that's going to be 12. You may need to see more then. Okay. Last thing then we have is one final theorem. This theorem does have a name, triangle angle bisector theorem. Now, if you look at all of the previous theorems we've done, we've had 2 triangles that were similar to each other in all of those theorems. This theorem, you're just going to have one triangle. And it's called the triangle angle bisector theorem. So what I'm going to do is bisect one of the angles. I'm going to bisect this angle over here. And when we do that, what's going to happen here, your angle bisector is going to split this opposite side into 2 parts. I'm going to call those 2 parts A and B. And what's going to happen here is these 2 parts are going to end up being proportional to the other 2 sides of the triangle. I'm going to call these sides C and B. And then the exact same thing happens. You've got 4 parts there. You're going to make a proportion out of the 4 parts. There's a lot of different ways to do it. What I'm going to do, since C and D are kind of on the left, I'm going to keep them on the left. A and B are on the right, so I'm going to keep them on the right. That's just one way you could set up the proportion. There's a lot of different ways you can do it. But when you draw in that angle bisector, it splits the opposite side into 2 parts. Those 2 parts will be proportional to the other 2 sides of your triangle. Any questions with that? All right, one example of that, and I think we'll be done. That's probably all you're going to need to see. The directions are going to tell you to find x. They're going to put an angle bisector in there. They're going to give us 3 of the parts we need. We're going to have to come up with the 4th part. And we know from our picture, we got these 4 parts. Those 4 parts are going to be proportional. Set up our proportion to do it. But before we can, we have to figure out what this missing part is right here. Because the 2 parts here are going to be proportional to the other 2 parts of the triangle. So I got to figure out what this part is here. So let's just do a little logic here. If this x was a 4, what would be left for over here? 16, because 20 minus 4 is 16. If this x was 9, what would this have to be? 11, because 20 minus 9 is 11. If this was 14, what would this have to be? 6. 20 minus 14 is 6. If this is x, what does this have to be?
20.
Close. Skylar?
20 minus x.
20 minus x. Whatever this number is here, we're going to subtract it from 20 to get what's left over. When we put a number in for x, we subtracted it from 20 to get this length. So do the same thing if it's an x. Subtract it from 20, that's going to be this length over here. Now, once you have that part, you've got your 4 parts you need for your proportion. Like always, you can set up the proportion in a few different ways. 11 and the 20 minus x are on the left, so I'm going to keep them on the left. 14 and the x are on the right, I'm going to keep them on the right. That's just one way to set it up. You could have set it up differently. Now we'll cross multiply. You get 11 times x is 11x. 14 times 20 minus x, remember that quantity you want to put in parentheses. And then we'll do our distributive property. Still have 11x on the left. 14 times 20 is 280. 14 times negative x is negative 14x. And then I'm going to move that 14x over to the left. If I add it to the left, 11x plus 14x is 25x. Get 280 here, and these become 0. And 280 divided by 25 is going to be a decimal again. That's going to be 11.2. Like always, don't be surprised if you get decimals for answers when you do this. All right, anybody need to see another one of these? Anybody need this explained again, how we got to 20 minus x? You'll probably see something like that on your test, your quiz, that come up with this. We're good with those? Okay, let's go to your packet of stuff for chapter 7. And we kind of got a couple things to do here. Your assignment for section 4 is this page 495 out of your book. And then for section 5, we've got, it's called quiz review 7.4 to 7.5. We don't have a quiz for 7.4 to 7.5, but this is going to be the worksheet you're going to do. This one right here is the worksheet you're going to do for your assignment for section 5. And that one is on the back of that mid-segment thing you just did. So the rest of the time you have to work on those two, the page from the book and the worksheet in the packet. And we can also bring back your GeoGebra thing you did yesterday. We can get that put in the grade book today. And that's it. The rest of the time is yours.
Is it okay?